Okay, we have a wide variety of lenses for this lab on the thin lens model of the eye, part 3, astigmatism. In order of what you'll use, we have a plus 10 diopter spherical lens, plus 5 diopter spherical lens. This is a plus 2.75 cylindrical lens, a minus 3 lens, a spherocylindrical lens, and a large Pierce cylindrical lens. And the first thing you'll do for these is use our with and against observations to characterize the power of each lens. I'll demonstrate that for this plus 275 cylindrical lens. I'm going to find some text, and I'll begin by moving this away from the text, and we can see slight magnification, and also against motion in the vertical direction, which tells me that's positive power. If I move horizontally, we see no relative motion. That means there's no power in that meridian. Positive power in the vertical meridian, 0 power in the horizontal meridian. Compare that to the plus 10, where I can see clear positive power against motion in both directions. Both meridians have positive power. In this case, with a negative cyl lens, I can find the axis, that's where the red lines indicate, and I can see that there is with motion vertically and 0 relative motion horizontally. Again, with motion vertically, 0 motion horizontally. So I can start to characterize all of these lenses. You'll do that with each lens, and then we'll design a table that illustrates the property of each lens. I'll demonstrate that table now. So for each lens, we'll characterize the lens and sketch it. So I'll do a demonstration of what we mean for this minus 3 test lens. So I'm going to sketch that lens like this. This is super awesome quality drawing here. Just make it clear what lens I'm talking about. And then I'm going to indicate the relative power of each meridian. So again, if I take this over to my text, holding it the way I've drawn it, I see that there is with motion, indicating negative power. So I'm going to draw that over here. Negative power on the vertical meridian. Then again, horizontal motion shows no relative motion. So I'll draw 0 power on that axis. Then you continue to do that for the other lenses. Spherical plus 10 lens, and so on and so forth. So I've auto-collimated the plus 5 diopter lens, and I can now place this large cylinder lens in front of that beam of collimated light. So we have collimated rays after that plus 5. And then I'll adjust the lens or the screen to find a clear line image. And that line image is going to look a little strange. It's a vertical line image because of the orientation of this lens, which means the object, horizontal parts of the object are not going to be visible. You're only going to see the vertical features, like that vertical arrow. Again, the arrow has a vertical and horizontal component. Only the vertical component will be in focus. So you see this is the vertical line image. Again, out of focus, that's a focused line image. Again, with the plus 5 diopter lens auto-collimated, we have parallel light leaving. We've added a plus 10 diopter lens and a screen to locate a clear image. Located the plus 2.7 in the holder with the plus 10 to create a spherocylindrical lens. You'll notice that I've oriented the axis vertically. Now we can locate 2 line images formed by this spherocylindrical lens. One of them is already here. That shouldn't be particularly surprising. Let's find the other one. Farther back? Nope. Should be closer. We'll let you explain why. And there's the clear vertical line image. Let's look at those again a little bit more closely. Clear vertical line image. Clear horizontal line image. Again, looking for clear features, either vertical features or horizontal features. So here's clear horizontal image, there is a clear vertical image. For part 7, we've gone back to the screen distance that we had at the beginning of part 4. This can represent an emmetropic eye until we add the cylindrical lens. Now we have an astigmatic eye for part 7. You will calculate and compare the location of these two line images using the Vergence equation, and then calculate the contact lens prescription you would expect to find as a corrective lens. You should have something close on the bench, and we can try that and see that in fact we're able to correct, as long as we orient the axis in the right place. There's a nice contact lens correction. Again, without correction, with correction.